engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the programme where we bring you the latest breakthroughs in science, technology and medicine with me, Chris Smith, and with Eva Higginbotham.
this week, the data on masks is mixed. Might it be that most people aren't using them properly? Also, are iceberg basements why Brian May's home flooded in London? And an app that can spot anemia from a selfie.
Plus, it is the Royal Society's annual summer science exhibition, but with a digital difference this year. We go behind the scenes to hear whether bees have favourite flowers and discover the smelly science of your armpit microbiome.
The Naked Scientists podcast is powered by ukfast.co.uk.
First, they weren't introduced. Then, they were mandatory. Then, with Freedom Day, they weren't. And now, confusingly, in some parts of the country, you'll have to go by whatever rules the local councils and businesses are putting in place for face coverings. In London, it is business as usual on the tube.
What we're doing in the absence of national legislation is using what's called the conditions of carriage. Basically, it's the contract you have when you want to use TfL services. One of the conditions you've got to abide by is the requirement to wear a face covering. And by and large, the great news is the vast majority of people over the last 12 months have used a face covering without the need for enforcement. I'm confident both Londoners and those visiting our city will continue to wear a face covering.
London Mayor Sadiq Khan. So why the controversy? What's the evidence these things actually work? And what does engineer Eugenia O'Kelly, who heads up Cambridge University's Respiratory Protection Engineering Task Force, think about the whole issue? Well, according to her, the signs are they can make a difference, but most people actually, when you look, aren't wearing them properly, and that's what's limiting the effectiveness. So you could say, are they fit for purpose?
There's two purposes that a face covering can serve. One is to protect others, and the second purpose is to protect yourself. In terms of protecting others, the face covering will prevent any sort of droplets that you exhale from being distributed around the environment. The second purpose of a mask is to protect yourself. And if you're wearing a mask to protect yourself, the engineering challenges of that are quite a bit higher. You actually want to be filtering all the air that you're inhaling. And for that, you have to have a material that has high enough filtration ability that it's going to be catching a sufficient number of viruses or pollutants. And secondly, and more challengingly, it has to fit well enough that air isn't just going to be leaking around the sides of the mask.
Is not another problem that when doctors, nurses, other healthcare workers in hospital use close-fitting masks designed to exclude viruses from the body, they're combined with other elements of personal protective equipment, such as aprons, gloves, scrubs, eye protection. The idea being that there are multiple routes into the body via various direct and indirect pathways, and you've got to close off all of them, or it's not worth the additional protection of these very, very stringent masks.
Yes, I would say that if you're really looking for 100% protection, you need additional measures. And we're doing a project right now on the amount of droplets that through normal speaking end up in the eye area and how different types of glasses that an average person might be wearing might block that. You certainly get quite a few droplets in the eye area when you're normally speaking with someone. And another thing to keep in mind is these healthcare workers, even with just the masks that they have gone through procedures to ensure the masks and the other PPE fit and work. So it's perhaps an unfair standard to expect for your average citizen.
When people do experiments to work out whether or not masks do arrest a lot of the stuff that's coming through them, do they actually do a comprehensive experiment where they look from behind as well as in front? Because a lot of the studies I've seen have just been looking from the side, looking at stuff being projected forwards, and they're ignoring the fact that, a lot of my colleagues who put face coverings on at work and wear glasses, their glasses are incessantly steaming up. Now that's showing you that there's a lot of material blowing up over the upper part of the face and is not being stopped by a face covering. So how good are your average face coverings at actually stopping these droplets?
I think that's a very good point, and one perhaps very good visual of how much escape you can get around the sides of the mask is if you watch someone in a very cold environment, you can see the vapor from your breath escaping around all sides of the mask is significant. And that's really a sign of poor fit. And while those masks are likely to hinder very large droplets that you're projecting when you're speaking, it's not really fitting well enough to filter those smaller particles.
Do you have a feel for, if you take a person at random off the street who is wearing some kind of face covering, how effectively they are wearing it?
Well, unfortunately, at this point, we don't have a significant enough sample size that we can really make that assessment. What we have done is we have created a tool so that if you're wearing a higher efficiency mask, such as a surgical mask, an FFP2 mask, or an FFP3 mask, you can at home perform the same type of test that a hospital performs on its workers to make sure that their masks fit.
Did you try it on yourself?
Yes, I did. Most of the experiments we've done, I've tried on myself while working out some of the kinks. And
Were you masking effectively?
I was not, actually. So I tried it on 5 different masks on myself. And what surprised me was, especially given the fact that I've been working with this, reading all of this literature, doing these studies, there were masks I thought fit. And when I tested them, they didn't.
It's interesting that, isn't it? Eugenia O'Kelly there. And if you'd like to download the instructions for how you run her face mask fit testing tool, then we've made that very easy. If you go to nakedscientist.com/mask, it'll take you to her research paper.
To a catastrophe of a different kind now. Major flooding in Europe has killed over 180 people last week, with more still unaccounted for. And many are pointing the finger at climate change as the cause behind this extreme weather, which also unleashed a deluge in London last week. One of the victims was Queen guitarist Brian May, who posted videos on social media of a torrent of sewage that had flowed into his London home.
Indeed, stinking black sludge flooded the floor, destroying childhood photos and memorabilia that he had stored there. The cause? Well, Brian May blames a rise in the construction of mega basements. These are so-called iceberg basements that, rather like icebergs, feature many stories hidden beneath the surface. Supposedly, these structures can stop groundwater from draining away properly. But is that actually true? Phil Sansom spoke to flood forecasting expert Linda Spate, who's at the University of Reading.
In London on Monday, there was a really heavy rainfall event. Kind of the average rainfall that's normal for the whole of July fell in just a couple of hours. The impacts of that caused flooding across the area, really. Lots of different areas of London were showing videos of flooded streets, flooded basements, flooded rainfall stations. And really that's the expected outcome from that amount of rainfall in such a short amount of time.
Of course, the consequence for people like Brian May is that stuff that's in basements can be damaged or destroyed.
Yeah, Brian May, unfortunately, this week suffered the experience that many people across the country suffer when flooding happens. And it's really devastating and emotional time that your property and your personal belongings and things that hold value for you as an individual get destroyed in the floodwater.
And Brian blames it on, in Kensington, where he lives, the so-called epidemic of people building huge mega basements many stories down beneath their houses. Is that a reasonable thing to blame it on?
I think when this kind of flooding happens, people are really keen to find somebody or something to blame. And there clearly has been a lot of basement conversions and basement development across London. And the reason for this is because there's no other space to build in the area. And the same's true of rainfall. So when it rains a lot in London, there's nowhere else for the water to go. There's lots of hard surfaces, and when the rain hits hard surfaces, it can't soak into the ground like it would do if it was falling in the countryside or in fields and grass and woodland areas. So that means, unfortunately, where people have built basements, they've actually built something that's below ground level, and the water wants to try and get to the lowest place possible, so it flows into the basements.
So is it these big basements that are letting this water build up and creating the hard surfaces that prevent it draining properly?
It's not necessarily the basements, it's just development in urban areas in general. I wouldn't like to say the basements have made any difference in this event. That amount of rainfall would have caused flooding anyway. They may or may not have contributed to it, but they're unlikely to have been a significant factor. It's more generally the fact that there is no space for water in our cities. And when it rains a lot like we saw last week, the water naturally has to flood because there's nowhere else for it to go.
So even if more and more basements aren't the problem here, Are these kind of floods still getting more common?
Anecdotally, it would seem that we are experiencing more of these heavy rainfall events in the last few years. And the climate change predictions seem to be backing up this statement, saying that as the atmosphere warms, then these kind of events will get more frequent in the future. And the reason for that being, warmer air can hold more water. That means that when it rains, there's more moisture in the atmosphere, and therefore more rainfall falls very quickly, and we see these heavy, intense rainfall events increasing in the future.
And how often is that likely to overwhelm a city's drainage, like we've just seen?
Cities in the UK have what we call combined sewer systems. That means that both our dirty water and the rainfall flow into the same sewer system. The problem is that the way we've designed those systems uses historical rainfall data. And as I've already said, we're seeing more and more of these events, and more intense rainfall is predicted in the future. So what was once a once in 30-year event may soon become a once in 20-year or 1 in 10-year event, and the sewer systems are likely to get overwhelmed more frequently.
I mean, what do we do? Because these sewer systems are built beneath a city. It's not as if you can just lift it up and enlarge everything and then put it all back down again.
No, it's probably not practical to redesign our sewer systems. Although we might be able to do that in small areas, we're not going to be able to do that across the whole cities, across the whole country. So what we need to do is actually make people more aware that they are at risk of flooding. And as we can see from Brian May's story, it's really devastating when it does happen to you. So in the UK, we're quite good now at forecasting these type of events. The Met Office did issue a heavy rainfall warning for the flooding on Monday. And what we need people to understand is when they see those kind of warnings, they need to start taking action. That might be that they don't want to keep their best possessions down in their basements where the water's naturally likely to go. They could also think about installing flood-resilient defences onto their properties, small gates that they put across their doorways, or making their property in general more resilient, moving their plug sockets higher up, putting damp-proof courses in, things like that. So there's lots of proactive ways people can take action themselves to help protect themselves from the impacts of flooding.
Tough though, isn't it? And we certainly have our thoughts with those people in Europe who have not just lost memorabilia, they've also lost their lives. We were hearing from Linda Spate there.
From baffling British weather
sideways spines of the vertebrae coming off here
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists In Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials wherever you get your podcasts.
Still to come in the programme, the app that can tell from a selfie if you might be anemic.
But first, you may share everything with your dog, from your bed to the food from your table, but recent research suggests that, unfortunately, those favours are not likely to be returned. Many of us are totally enamoured with our dogs and feel that we would do almost anything to keep them warm, happy and, importantly, fed. And we might like to think that our dogs would return the favour and, given the option, feed us too.
After dogs had been trained to use a food dispenser, dogs experienced a helpful human which provided them with food using the food dispenser, and an unhelpful human who didn't provide them with food.
That's Jim McGettrick from the University of Veterinary Medicine in Vienna, and he set out to see if dogs would choose to feed humans by interacting with a food dispenser they themselves had been fed with. But, unfortunately,
the dogs didn't reciprocate the receipt of food, so regardless of whether the human had been helpful providing food or unhelpful not providing food, the dogs didn't provide food in return.
Despite conventional wisdom that your pup is going to love whoever feeds them, the researchers also didn't see any difference in how the dogs responded to the people who either fed or didn't feed them. Though Jim pointed out it may be that building that kind of relationship just takes some time.
It's important to note in our experimental setup, it was an artificial setting, let's say. There was no communicative interaction of any note between the human and the dog, and there was also no physical contact. And with most natural cooperative interactions, so for example, like you see in primates grooming each other, you've got very clear physical interactions. So it's very difficult in those situations to ignore the fact or to not notice the fact that another individual is doing something nice for you.
So perhaps the dogs just didn't fully understand that they were being fed by a human, and as such, it might be nice to return the favour. But do dogs even show these kinds of behaviours with other dogs?
Our group previously showed that dogs will provide food to other dogs in a similar setup. And what's interesting there is the dogs did provide food to partners, but only if those partners were familiar to them, in most cases meaning from the same household.
Friends and family only then. Importantly though, food sharing just doesn't seem to be a natural behaviour for dogs, as many dog owners could confidently attest, unlike other animals like some primates for whom food sharing is the natural order of things. And it turns out the theories for how these behaviours arise in the brain are still not completely understood.
Previously, it was generally kind of assumed that to reciprocate a cooperative behavior, you require a lot of complex cognitive abilities. For example, a very complex memory, the ability to stop yourself from consuming a particular resource so that you can give it to another individual, the ability to plan, to know that if I give you this resource, that will result in me getting some resource from you in the future. But the tide has kind of shifted on how we view reciprocal cooperation, or how it's likely that it comes about in animals. So now the view is more that most reciprocity in animals is probably a more emotionally based interaction. So for example, if you imagine two primates interacting, they groom each other, and this results in the development of a relationship, which as a consequence results in this kind of reciprocity with regards to grooming. But it's not necessarily the case that those two individuals are thinking about that and calculating, okay, well, that individual gave me 10 units of grooming last time. I'm going to give them 10 this time. Or last time they gave me less than I gave them, so I'm going to, change it. It's probably more likely that the receipt of grooming or whatever other cooperative act results in a positive attitude towards that individual.
So perhaps reciprocal behaviour in animals could be thought of more as a warm bond with another creature, as opposed to a calculated tit for tat. That said, if a dog wouldn't feed me in return, I might as well just stick with my cat. Jim McGettrick, and his paper was just published in the journal PLOS One.
Anemia is a common condition that makes you feel very tired and weak, and it's caused by a lack of iron-rich haemoglobin that's present in your red blood cells. People who lose a lot of blood, don't eat a good enough diet, or they have diseases that affect the ability of the body to produce red blood cells can all get this condition.
Now, anemia is actually usually very easy to treat, but it is often greatly underdiagnosed, mainly because right now the way you test for it is a bit inconvenient. It involves taking a blood sample and waiting for this to be analysed in a lab. But now researchers at Brown University have found a faster way to spot it, which can be done in literally the blink of an eye, as Sally LePage found out.
Okay, I've got my phone on selfie camera mode. I'm holding it as close to my face as possible until it can no longer focus. I am pulling down on my lower eyelid and there we go. A terrifying image of my inner eyelid. Now, as a young millennial, I've probably taken more selfies than the average person, but this is a strange thing to be doing even for me. However, this may become a more normal activity in the future, as a team of researchers at Brown University and Rhode Island Hospital have figured out a way to use photos of people's inner eyelids to test for anemia, as I heard from lead author Salim Suna.
There are blood vessels very close to the surface of the inside of the eyelid, and they come together to give the inner eyelid a red hue. And that's primarily what we're extracting from those images is that red hue. And using some fancy math and image processing to extract the redness of the inner eyelid. And the less red it is, the more likely that that person has anemia.
Anemia is a lack of red blood cells in the blood, and in severe cases can make you seriously ill or even be fatal. And anemia is incredibly common too.
It's thought that about a third of the world's population is anemic to a certain extent. And this is more pronounced in developing countries and in countries where there are parasitic diseases such as malaria, and also nutritional deficiencies can cause anemia as well.
Right now, the gold standard test for anemia is a blood test, but Salim's team hopes to be able to develop this eyelid photography test into an app for any smartphone. But what's wrong with a simple blood test?
Well, you would have to make an appointment with your GP. They would have to order the test. You would have to go to a lab, get your arm or hand stuck with a needle, and then wait for the results, which would probably take a few days. Whereas if you had this app, you can take a picture of your lower eyelid and have the results in seconds. It's that fast.
Sounds simple, right? But is it accurate?
So our test is about 70 to 80% accurate in determining if someone is anemic, and skin color does not affect our results. So one use is that we could screen populations with this test, and those that come up anemic on our test would go on to get a blood test and get treated. So that would save resources.
Are there any other ways this is more appropriate than a blood test?
In time-sensitive conditions, for example, after a car accident, this test could be performed with the phone in the ambulance. And if a patient is losing a lot of blood, then we could figure that out very fast.
I hadn't thought of that. I always think of anemia as something that comes on gradually because of diet. But I suppose if you're losing a lot of blood, you're very quickly going to become anemic.
Absolutely. And that could occur from traumatic conditions where there's bleeding either internally or externally, or from gastrointestinal bleeding, which is a common cause of anemia.
You said anemia is more common in developing countries, and I imagine it's much harder to get a blood test there. But are there enough smartphones with good enough cameras for your app to be useful in those countries?
We've looked into that, and even though the number of people with access to portable phones with cameras is less in developing countries, this number is growing significantly over time, and it's not as low as people think. For example, in Africa, the penetrance of cell phones with cameras is about 30%.
It's going to take a bit more research to turn this image analysis into a simple app that works on the majority of phones and doesn't require any training to use accurately. So for now, I can thankfully delete all of the photos of my inner eyelid from my phone, but I'll be keeping a close eye on how this develops over the next few years.
She could make some sort of weird slideshow, I'm sure. Salim Suna with a new phone test that has the ability to make people very happy indeed.
Brilliant piece of technology. What a great idea. Now, it's well known that dark surfaces soak up more of the sun's rays than lighter shades. And now new research suggests that some birds have evolved darker wings to take advantage of this heating effect and improve the efficiency of how they fly. This is particularly relevant for seabirds like albatrosses that have to travel across thousands of miles in a single journey. Harrison Lewis spoke to Savannah Regala, who's been putting wings in wind tunnels to get a bird's eye view of the evolutionary advantages of having darker plumage.
There have been some studies suggesting that the heating of an airfoil, like a wing, can actually improve the flight efficiency. But until now, there's been no studies whether color in birds can actually affect flight performance. So in my study, I found that darker wings will heat up more, and the hotter wing surface can actually increase the flight efficiency.
And this is wild because you're saying that a darker wing is more efficient in terms of energy for flight, but most birds are completely different in colour.
Yeah, that's definitely true. So birds are amazing because they have all kinds of colors. These colors serve different functions. So for example, very bright and shiny colors can serve for sexual signaling. But of course, not all birds are very colorful. So some are also more dull, so more like brownish, grayish.
It's a sort of camouflage, I guess, is it?
That's camouflage, exactly. So in our study, we've looked at seabirds. Seabirds are mostly black and white. And we found that birds that are already efficient in flight have evolved darker wings. So already efficient birds can increase their efficiency even more by becoming darker and by flying under the sun.
Right, and Savannah, how does one go about finding out if darker pigment in the wing helps with flight or makes flight more efficient? What are the steps?
What we did was to look at the wing in the wind tunnel. So we mounted a stuffed bird wing on a force balance. Then we could measure the forces applying on this wing, so the lift and the drag. And does the heating of the wing affect the flight efficiency? So therefore we also mounted some light bulbs in the wind tunnel, so it would simulate a bird flying under the sun. And then we compare the heated wing with the non-heated wing, and we found that the heated wing is 20% more efficient.
And why is that?
So that's actually what we would need to test in the future, but we have some hypotheses. So it could be that the boundary layer, so the air flying around the wing, is delayed when the wing surface is heated. And by the heating of the wing, it could be that the boundary layer is separated at an earlier stage, so that could make the flight more efficient.
When air passes over a curved surface, like a wing, it sticks to it. And in part, this is responsible for generating lift. But if it isn't optimal, it can actually hamper the efficiency of the wing's performance. Savannah believes that heating the wing alters how long that passing air sticks to its surface, making the process much more efficient. So, is one implication of these findings that we should be painting all our aircraft black?
Unfortunately, it's not that easy. Of course, a plane will fly much, much faster than a bird. On the other hand, planes also store the fuel in their wings. So it's also not ideal to have the wings heated up in that case. So.
That doesn't seem ideal at all.
Yeah.
Back to the drawing board with that one then, Harry. He was talking with Savannah Rogala.
Much has changed for business owners, managers, and staff recently. But with over 30 years' experience in telecommunications, award-winning independent company Spitfire have the expertise to make sure you stay ahead and can keep on innovating. Whether it's connectivity, MPLS networks, firewalls, or phone systems, Spitfire can help. To find out more, go to spitfire.co.uk. That's spitfire.co.uk. Spitfire, telecoms and IP engineering solutions for business since 1988.
Music in the programme is sponsored by Epidemic Sound. Perfect music for audio and video productions.
For the rest of the programme this week, we're going behind the scenes at the Royal Society's Summer Science Exhibition, which has been happening online this year. Wait for it, because of COVID.
Indeed. Now, the Royal Society was established a long time ago, 1660, by the acclaimed architect and astronomer Christopher Wren. It's actually the oldest national scientific institution in the world, and it exists to promote, fund and advise on scientific matters. And although for many years its meetings took place behind closed doors, it later started putting on shows and demonstrations for the public of the latest scientific research, which would have been quite a spectacle at the time, as I heard from Chief Librarian Keith Moore.
I would have loved to have gone to a 19th century Royal Society exhibition. The place would have been fizzing with floral displays, displays of electricity. Great scientists were there, so you might have talked to Michael Faraday or James Clerk Maxwell. And the exhibits were very eclectic, so yes, there was great science there, but you might also have seen art by the latest pre-Raphaelite painters, or materials sent to the Royal Society from all parts of the world, so rough diamonds, rubies, manufactures of different countries. It generally was a mixed bag of things. So the great scientists of the Royal Society we've all heard of, people like Isaac Newton, Benjamin Franklin, Howard Florey in the 20th century, Albert Einstein was a foreign member, and it's surprising how many of these people exhibited at the Summer Science exhibitions. Alexander Fleming, who developed penicillin, showed his early research at the Royal Society just after the First World War. So some very famous people have showed their science, and Summer Science exhibition continues in that tradition.
So this week we're going to hear about some of the modern day exhibits you can check out online and the science behind them. And we're going to be hearing more from Keith about some of the old examples too. To kick us off, some research into insect behaviour, and animals have been a feature of the exhibition for hundreds of years.
There's a famous magazine illustration which shows a lady looking at an electric eel in a case at the Royal Society, and they were administering shocks to visitors just to demonstrate the properties of the creature. Jimmy the dog, who was the pet of Augustus Waller, helped in the exhibitions as well. He demonstrated his own heartbeat from Waller's electrocardiogram, and questions were asked in Parliament about that. In the 17th century at Royal Society meetings, if someone discovered at a London market, for example, an interesting fish, they might well bring it into the Royal Society. In Newton's presidency, a German gentleman was given 10 and 6 for making his dog talk, and apparently it was a very talented dog. It spoke in English, French and High Dutch.
Well, you can't get dogs like that these days, can you? But talking dogs aside, important research into animal behaviour is on display in this year's exhibition, and specifically bumblebees. Now, bumblebees are crucial pollinators in nature's ecosystem. Farmers will buy commercial beehives and put them in their fields in hopes that they're going to do the hard work of pollinating their crops for them. But do they actually do that? Well, Ellie Kent's a PhD student at the University of East Anglia, and she's trying to find out. How are you doing it?
Hi, so we want to know which flowers the bees have been visiting on the farm. I've been working on soft fruit farms where you have a large area of one crop, so you might expect the bees to visit the most abundant flower, which would be the crop. But bumblebees can fly 1 kilometre to find food, and even farms have really diverse habitats with lots of different flowers in. So we want to know which flowers the bees have been visiting. And one way to do this is by studying the pollen that bees collect. So pollen is a really important part of a bee's diet because it's high in protein and fat. And bees make foraging trips where they collect pollen from flowers and take it back to their colony. So we can take that pollen from the bee and see which flowers the bee has visited.
And how do you actually do that, Ellie? How do you know which pollen came from which flower?
Previously, it would have been done using microscopy, which takes a really long time, and a lot of the closely related species are very similar.
So you mean actually physically putting bits of pollen under the microscope in order to identify which plant it came from just on the shape and size of the pollen grains?
Exactly.
Oh, goodness, that sounds like a bit of a nightmare.
It is. It takes a really long time. I've actually had a go at doing it, and I can confirm it's pretty time consuming. So what we've been doing is looking at the DNA in the pollen. So we can use the DNA as a code, which is unique to each plant species, and then we can use that to identify the flower the pollen has come from.
What did you do then? Collect a whole bunch of bumblebees and scrape the pollen off, and then get the genetic codes of all the pollen and then marry it up to flowers or plants?
Yeah, pretty much. I've done some field work where I've collected about 1,000 pollen samples from bees. And you can scrape off the pollen because they collect it into these balls on their hind legs, so it's quite easy to get. And then we can extract the DNA, and with this small device called a MinION, it can take just a few hours to tell us what the pollen DNA is. And then, like you said, we can compare the pollen DNA to plant DNA, and the ones which are most similar provide that match.
So you can actually work out then basically what the bees have been dining out on. You better put us out of our misery. What do they actually go for? Do they do what the farmers want, which is to pollinate the monoculture of the one crop that's growing? Or do they think, actually, I'm a bit bored of that, I'm going to go elsewhere?
Of course, it's never that simple. Bees don't really have a favourite flower. It really depends on the species of bee, the time of year, so what's in flower at that point in time, what the landscape looks like, so how much of it could be agricultural or woodland. But what we do know is that bees do require a really diverse diet. So whatever landscape they're in, they will be going to several different flower species.
In other words, if they were to get a restaurant of all the same fast food chain, they would actually actively seek out to dine somewhere different from time to time. What can farmers do then, given that their motivation is they want their crops pollinated? This will give them the best yields, and that will make them the most commercially revenues. What can they do to tempt the bees to actually get the most efficient pollination?
So the results have shown that bees do prefer some types of flower, and we can use that information to build up a more sort of pollinator-friendly landscape. So we can plant more of these flower species in, say, hedgerows and field margins, and that will help wild populations of bees. And so that's sort of win-win situation for the farmers, because then they don't have to depend on buying bees. They can use this natural resource where the wild bees are doing the same job as ones they fought.
Jeremy Clarkson did this in his farm series. I don't know if you've caught any of it. In his farming series, he actually literally mowed down the crops down the middle of his field and planted a big strip of wildflowers. And the motivation was to try to tempt the pollinators into the middle of the crop rather than just from the edges.
Yeah, that's a really great idea, to get more of these wildflower areas where you're getting flowers at all times of year, not just when the crop is flowering. You're going to get a much more diverse range of insects, which will do the same job.
I never thought we'd be mentioning Jeremy Clarkson on The Naked Scientist. And just in 20, 30 seconds, if people go online to see your exhibit, what can they find out about it? What can they learn about if they come to your exhibit, Ellie?
So we've got a short film where we talk in more detail about pollinators on farms and how we've been studying the DNA. And there's a short game where you can have a go at collecting the DNA. And there's also a citizen science questionnaire about how bee hotels are used by the public. So it'd be really fantastic to get lots of responses from that.
We wish you luck. Ellie, thanks very much for joining us to tell us about it. Ellie Kent there. Now, this week we are looking at the Royal Society Summer Science Exhibition. On the way, how scientists are tracking where the carbon that we pump out into the atmosphere then ends up in our oceans.
But first, with the summer heat we've been experiencing here in the UK, some may suspect that they've been a bit smellier than usual. Well, that is down to the bacteria that live in our armpits, and in a moment we'll hear more about how understanding those bacteria better could lead to superior deodorants. First, though, let's rejoin the Royal Society's Keith Moore and see how microscopes and the formerly invisible world of microbes that they enabled visitors to see have always been a huge hit over the years.
Microscopes were a really important part of how science was demonstrated in the 19th century, and one of the great pioneers, Robert Koch, the germ theory pioneer, sent specimens of tuberculosis, leprosy and other bacteria for exhibition by William Watson Cheney in 1882. And of course later Koch would go on to win the Nobel Prize for his tuberculosis research. Visitors to the Summer Science Exhibition would be able to look down microscopes and use them. They would see interesting things down there, perhaps minerals or small creatures. But scientists attending might be interested in the instrument itself. So instrument makers would demonstrate their wares at the Royal Society in the hopes that scientists might buy one of those instruments.
Nowadays, of course, a lab wouldn't be a lab without a microscope, and some scientists do choose to use theirs to stare at what is living in the average armpit. The University of York's Gavin Thomas is one of those scientists. So, Gavin, is it the sweat then that makes humans smell?
So, hi Eva. It's the microbes that make us smell. And to understand that, we need to think a little bit about what sweat is and the different types of sweat that there are. So if you look in our armpit, it's a very rich environment with different types of sweat glands, but the type of sweat glands that we normally see on our open skin, which are called eccrine sweat glands that make the kind of salty water we know that we use for thermoregulation, they are found in the underarm, but also another important type of glands called the apocrine glands. And these apocrine glands make different types of sweat, which contains a range of different chemicals, but also the odorless precursors that are acted on by bacteria to form the molecules that we know as body odour.
And what kind of bacteria are they that live in the armpit?
We've discovered some particular bacteria called Staphylococci that were important in this process. There's lots of different types of bacteria that live in the underarm. We like to think of it as a bit of an oasis on the skin. So the skin has different parts, the open skin, scalp, for example, your feet and your underarms. They're all different environments and they all have their own populations of microbes. So the underarm has a particularly rich set of microbes, a very diverse set of microbes, and only some of those are actually able to make body odour. And we've kind of pinpointed the ones that are able to do that.
And do those bacteria like to be in the armpits because they like to eat the molecules that are in that sweat you were talking about?
Yeah, we think so. I mean, we haven't formally proven this yet, but we know that these odour precursors, when the bacteria take them up, they take them up first into their cells, and then they actually partly break them down, and they eat the things that they're releasing. So they release nutrients from those molecules. And then the final molecule that they can no longer use, they then spit it out. And that molecule is the volatile molecule that forms one of the most pungent components of body odor, which is called a thioalcohol. So we've been working on discovering how these particular bacteria recognize this odorless precursor, take it up, break it down, producing what we recognize as BO.
And does everyone make the same molecules and so smell the same? Because some people just are smellier than others.
Yeah, that's a great question. There is a genetic basis behind this in terms of the amount of those odorless precursors I just mentioned, about how much are actually made. So we know that there are some populations of people in the Far East who have a genetic mutation in the enzyme that actually secretes the precursors into the underarm. So these people don't make or don't secrete as much of the precursors and therefore aren't able to make so much thioalcohol. Now, they do still smell, but they smell differently to a Caucasian person because they're missing that key component of the body odor. Body odor is made up of a range of different molecules. The thioalcohols that we study are the most pungent component. So without them, they actually smell slightly different to what a Caucasian person does. And also the actual population of microbes in the underarm clearly has an effect because we know that some people have produced higher or lower levels of actual body odor. So at least two things influence that.
And can we try and use this understanding of this breakdown of these molecules in these specific bacteria to try to make better deodorants and so people can smell less?
Yeah, so that's what we're trying to do, and that's what our colleagues in Oxford are looking at. So because we've discovered how the bacteria take up those precursors and how they break them down, we can try and design targeted drugs that will inhibit that particular process. So that's, we think, is better. If you look at current deodorants and antiperspirants, which either kind of mask body odor or prevent the precursors being secreted, many of them contain a kind of a general antimicrobial, things like triclosan. These will kind of affect all the microbes in the underarm. And what we really want is to try and design something which will just specifically hit the microbe, which we've discovered, which is called Staphylococcus hominis, that makes the odor. So this information should be able to help us make a much smarter deodorant.
So it'd be like some kind of very specific armpit antibiotic that would just knock out the specific bad smelly ones?
Well, not even an antibiotic in the sense we don't even need to kill the bacteria. We just need to stop that particular process. So the idea is that we really go in and stop the transporter taking up the precursor, and we're not killing the bacteria, and we shouldn't be changing the microbiome too much. So it's a really, really kind of guided weapon to inhibit the particular process that leads to odor production.
So there you go. We often think about trying to keep our gut microbiome happy, but perhaps we should be thinking more kindly of our underarm microbiome. One of my questions is, what is the point of all of this? Is there any reason that the bacteria should be in our armpits breaking down these molecules in this very specific way? How could this have evolved?
Yeah, that's a great question, Eva. I mean, that's what we're really trying to understand now, because we understand which bacteria do it, how they do it, but not why they do it. So our research has suggested that the production of this thioalcohol molecule is a pretty ancient process. So it certainly predates our split from other higher apes. So it's been among us all the way through human evolution. And we know that other mammals use microbially derived volatile chemicals to communicate with each other.
Is that what a pheromone is?
Exactly. That is the definition of a pheromone. It's a volatile chemical that's used to communicate between animals of the same or potentially different species. So these might be human pheromones. In our evolutionary past, they might have been important to humans in terms of communicating.
And do you think they could be important to humans in communicating now? Is there anything we could be doing by being quite clean these days and washing our armpits and applying deodorant? Could there be some benefit that we're missing out on?
That's a difficult question to answer. I mean, we know that if you go back a couple of 100 years, we all had a strong odour. That would have been part of our personality, our character. And then the Victorians come along, they associate odour with illness, and therefore, as part of cleaning up the cities and the environment, they get rid of smells. Smells are linked to disease. And that, on the whole, is a very sensible thing to have done. So we have an environment now where we have a lot fewer smells in our environment. And again, in the early 20th century, a lot of soap companies really rammed home the idea that BO was bad to sell their products. So it's difficult. Is this conditioned in us? Is BO really actually bad? And again, I always like to make this nice quote that Napoleon famously apparently wrote to Josephine when he was returning from the battlefield, where he said, "I'm coming home, don't wash." So clearly for Napoleon, the unwashed smell of Josephine had a positive association for body odour. Whether there's any direct benefit now, it's difficult to say.
So more research to be done then. So Gavin, what can people see if they check out your stall online?
So we've got a great arcade game called Backman. You can play a Staph hominis, which is the bacterium I've been talking about. You can go around and try and defeat the other skin microbiome and eat odour precursors. And on the website, you can read much more about the science behind what I've just been talking about. And also there's a quiz there too, and also some videos from the Oxford team saying about how they're developing these new drugs to try and reduce body odour.
Brilliant. Thank you very much. That's Gavin Thomas from the University of York.
Never thought I'd hear a link between Pac-Man and BO, but there we are. Up into space now. And these days, of course, we take for granted that we can take pictures of the Earth from space. But in the past, of course, scientists were chiefly focused on taking pictures of the heavens from down here on Earth.
Photography was an important part of the 19th century summer science exhibition. So people like Norman Lockyer, the astronomer, would demonstrate very regularly photographs of the latest discoveries. But also this was an area where some women scientists got involved. The Irish astronomer Annie Maunder showed her photographic skills at several summer science exhibitions in the 1890s. So this was an exhibition that women were beginning to participate in as well as men.
Nowadays, we can look down at the Earth using cameras mounted on orbiting satellites, and we can use this sort of thing to study weather patterns so we can predict storms and heat waves. We can monitor how the continents are moving around and where the land is bulging, which might presage a volcanic eruption, or where pollution and other gases are moving to. One group who are doing something like this and using this technology are looking at how tiny marine green plants called phytoplankton are taking up the carbon dioxide that we pump out into the atmosphere into the ocean. And Gemma Kolk at the Plymouth Marine Laboratory is one of them. How on earth do you spot a microscopic plant in the ocean from space, Gemma?
It seems a huge contradiction that we can see phytoplankton from space because indeed they are so small. But collectively, so all phytoplankton together, become visible through their impact on the color of the ocean. So the greener the water, the more phytoplankton there are. So similar to plants on land, phytoplankton are green.
And what are they actually doing with the carbon? How is the carbon going from the atmosphere and ending up in these plants in the ocean then?
So phytoplankton photosynthesize. If you are familiar with the process of photosynthesis, that means that phytoplankton use sunlight, so energy from the sun, to convert carbon dioxide and water into oxygen and organic particles.
And so if they're doing that to grow, is your sort of inference then that the greener the water is, the more they're growing, and therefore the more carbon they must be using?
Exactly, that's true.
And how precise is that? So if I've got a camera watching the ocean, how subtle is the difference in greenness, and how accurately does that map onto what the phytoplankton are actually doing when you look from space?
So the satellites that we are using in the open oceans, such as the North Atlantic Ocean, for example, have a resolution of 300 meters. So for every 300 meter by 300 meter square, we have an image, we have data available. If we look closer to the coast, we have a resolution of up to 30 meters, which is very high resolution. So we can see phytoplankton in quite a lot of detail. And the colors, it's not just the green color that is measured, but there are different colors that we use to identify phytoplankton. So yeah, the precision is quite high.
And what are you learning through doing this? Have we spotted anything that we didn't realise before, or are you able to just confirm, yep, we pump out CO2, it goes into the atmosphere and it ends up in the ocean?
Well, I think that's true. But what I find really exciting about my work with satellites is that we can watch the entire ocean at the global scale for very long periods of time. So the ocean color satellites that we now have a record of over 2 decades, so over 20 years of data, which is really exciting because we can watch phytoplankton over those 2 decades and see what happens. So what scientists originally thought that maybe phytoplankton globally was decreasing over time. So there's less phytoplankton now than there was 20 years ago, but we don't actually see that at the global scale. It seems to go up and down a little bit, so we don't see a clear trend or a clear decrease or increase.
Now, we heard earlier in the programme about the issue of climate change, and that's never far from anyone's mind, is it? Can this be useful in terms of monitoring where carbon's going and how we mitigate against climate change? Because we think carbon's at the root of climate change, don't we?
Yes, definitely. I think the oceans play a really important role in the global carbon cycle, and we often forget about it because it's not very visible. But phytoplankton take up about 50 gigatons of carbon each year, which makes them equally important to all plants on land. So they're really essential. And that also means that they play a role in climate change. What we do not know yet is how phytoplankton respond to climate change, because our time series of over 2 decades is not quite long enough to understand the changes that are occurring at the sort of climate change scale. So this is something that we have to wait for. We gather more data, but it might take us another 10 years to have a better understanding of that.
Of course, something we don't have to wait for is to come and visit your virtual stall for the Royal Society Summer Exhibition this year. So what will I see if I come and inspect your wares?
So hopefully you will see loads of phytoplankton, but there are also other things to see. So people can explore the global carbon cycle from space, not only in the oceans, but also how carbon moves through the atmosphere and is stored on land. It was very much a collaboration between different scientists, so we are looking at the total global carbon cycle.
Sounds brilliant. Thank you very much for telling us all about it. I shall beat a path to your door and have a look. Thanks, Gemma. That's Gemma Kolk.
Wonderful examples there of how science from the past and science from the present is making things better for us here on Earth and the animals around us too. Now, if you want to check out the exhibition, you can head to theroyalsociety.org.
And now it's time to wrap up the programme in our customary fashion with our question of the week. And Sally LePage has been tearing her hair out trying to lick this question from listener Beth.
My dog is always licking her fur but never gets a hairball. Why don't dogs get hairballs?
A hairy question indeed, so we've coughed up 3 animal aficionados to help get to the root cause. And to start, we've got Nick Sutton, Science Communications Advisor at the Kennel Club.
Well, actually, dogs do sometimes get hairballs, as can rabbits, ferrets, cows, and even humans. When animals groom themselves, any hair they swallow usually passes through their digestive tract and is excreted in their faeces. If too much hair is swallowed, or if it wraps around any food items, it can form a clump that's too big to pass out of the stomach. As more hair is swallowed, it clings to this mass and begins to grow in size. Once it's big enough to cause discomfort, the affected animal will usually vomit it up, as long as they can vomit, unlike cows and other ruminants.
You know, I had never thought about whether cows can vomit until now. Of course, cats famously get hairballs, so why is Beth's dog hairball free when her feline friends aren't?
Hairballs are a lot less common in dogs than cats, and this is for a number of reasons.
That's Justine Shotton, Junior Vice President at the British Veterinary Association.
First of all, dogs do lick themselves, particularly their paws, for example, but they don't groom their whole bodies in the same way that cats do. Cats also have tongues with small backwards pointing spines, which can help them to groom their entire bodies and pick up a lot of fur in the process, particularly if they're long-haired. Dogs' tongues are much softer, as you'll know if one of your canine friends has ever given you an affectionate lick.
And it's not just that dogs swallow less fur, they also find it easier to digest, as Anne Hohenhaus, staff doctor at NYC's Animal Medical Centre, explains.
Cats are obligate carnivores, meaning they are designed to eat meat. Carnivores have a shorter digestive tract than omnivores and vegetarians because digestion of meat is simpler than digestion of a vegetarian or omnivorous diet. Dogs are omnivores and thus have a longer digestive tract, which may be better at digesting hair than the short cat digestive tract.
And finally, it's still worth keeping watch if your dog does get hairballs.
Although it's unusual for dogs to get hairballs, they may be more prone to them if they have longer hair or if they lick themselves more often. If a dog does get a hairball, it could be a sign that they're licking themselves to relieve stress or anxiety, or to soothe any areas that are painful, uncomfortable, or itchy.
If you notice your dog vomiting up hairballs or passing a lot of hair in its poo, do always speak to your vet for advice.
Our next question of the week is this short but puzzling question from Henk.
Is lava wet?
So what do you think? Why not join in the debate on our forum? That's at nakedscientist.com/forum. Or if you have a question of your own that you'd like us to answer for you, then use the web form at nakedscientist.com/question or email us, chris@thenakedscientist.com. That is it for this week. Thanks to Eva who put the whole thing together, and do be sure to tune in at the same time next week because it's Q&A time. You ask the questions, we'll be supplying the answers. What have we in store for you? Well, as a bunch of billionaires head into space boffin Richard Hollingham joins us to talk about the future of orbital tourism. As we lurch toward even higher numbers of COVID, public health specialist Linda Bald will be answering your pandemic quandaries. Eleanor Drinkwater talks insects and the trade in illegal wildlife. And with the Olympics kicking off next week, Paralympian and physiologist Dan Gordon takes up the exercise baton for us. Join us for all that next week. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. We're supported by Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.